Hi, good morning. Welcome back to the 5-minute Econometrics. Today we will explore the quadratic form of the explanatory variable in the model. Quadratic functions are often used in applied economics. For the model with only one explanatory variable x, the estimated equation with a quadratic form of x looks like this. It captures an increasing or decreasing marginal effect of x on y hat. The marginal effect equals the slope of the fitted curve. It equals beta 1 hat plus 2 times beta 2 hat times x. It is a function of x. It means the marginal effect of x on y is not a constant, and it changes with x. We can take the second derivative and obtain 2 times beta 2 hat. It is the change of the marginal effect or the change of the slope. Whether the change of the marginal effect is positive or negative depends on beta 2 hat. If beta 2 hat is positive, the marginal effect increases with x. It corresponds to a curve with an increasing slope in the xy space. On the contrary, if beta 2 hat is negative, then the marginal effect decreases with x, which represents a curve with a decreasing slope. By contrast, a constant marginal effect implies a straight fitted line with a constant slope. Next, we will focus on the case in which beta 1 hat is positive and beta 2 hat is negative. That is the case we usually see in econometric research. In this case, the fitted curve bends downwards, and the marginal effect or the slope of the curve is diminishing. The marginal effect of x on y becomes smaller and smaller. It corresponds to the diminishing marginal benefit or diminishing marginal utility theory in microeconomics. For instance, production usually increases at a decreasing rate as more labor is used. In other words, the marginal product of labor is diminishing as more and more workers are employed. Let us have a look at the model that relates hourly wage to workers' experience. The model contains the quadratic form of experience. The marginal effect of experience on hourly wage is as follows. It depends on experience. Since its second derivative, 2 times beta 2 hat, is negative, the marginal effect is diminishing. The fitted curve bends downwards. For curves like this, we can always find a turning point at which the slope equals 0. At the turning point x star, the marginal effect becomes 0. Before x star, the marginal effect or the slope of the curve is positive. After x star, the marginal effect or the slope of the curve becomes negative. We equate the slope to 0 and find that x star equals minus beta 1 hat divided by 2 times beta 2 hat. In our example, when experience reaches 24.4 years, the marginal effect of experience on hourly wage becomes 0. After that, 1 more year of experience has a negative marginal effect on wages. There are 147 workers in the sample who have more than 24.4 years of experience. Does it make sense that one more year of experience leads to lower hourly wages? No, it may not. The estimate is very likely to suffer from the omitted variable bias because we have not controlled for any other relevant variables in the model. Another reason is the non-normal distribution of the outcome variable. These issues result in invalid statistical inference. To alleviate these problems, we add education and its quadratic form to the model and use the logarithmic form of the hourly wage as the outcome variable. The experience still exhibits diminishing marginal effect on the hourly wage. The turning point is at 28 years of experience now. The quadratic relationship is illustrated in the graph. Let us look at the estimates for the variable education. The marginal effect of education on wages is also called the return to education. It equals beta 3 hat plus 2 times beta 4 hat times education. Beta 3 hat is negative and beta 4 hat is positive. It is the opposite of experience. The fitted curve is U-shaped. It captures an increasing return to education. We can also find the turning point. It is at 4.6 years of schooling. Only 7 individuals have received an education of fewer than 4.6 years, about 1% of the sample. It is so small that the quadratic to the left of 4.6 can be ignored. Education exhibits an increasing marginal effect on the hourly wage. We can calculate the return to education at some typical points. The mean of education is about 13 years. The return to education is around 0.22 at this point, implying that one more year of education raises hourly wages by 22%. The 90th percentile of education is 16 years. The marginal effect of education on wages becomes 26%, illustrating an increasing return to education. Today, we have discussed the quadratic form of the explanatory variable in the regression model. It captures an increasing or decreasing marginal effect of the explanatory variable on the outcome variable. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.